now you have an idea of what to expect for that last question on the final. Let's see here. You guys are my hardcores, showing up on the last day. It is. Well, sort of. They're all the most important days. Exactly. So because you guys are my hardcores, that's okay. You're probably the only ones who would be interested in, so there's going to be an SL, do you guys know SL, supplemental learning? So there's someone who's been sitting in on classes, not ours, but other classes, and then they host kind of review sessions. So there's going to be a review session that's open to everyone in business math, okay? And so they'll have materials put together, and then we'll kind of work through practice problems. Just for staffing, they need you to sign up, okay? It's kind of I don't know. If you plan on going, then sign up. If you're not sure, it's probably better to just show up than to sign up, because I would hate for them to think that they have 10 people coming when they only get 2, that kind of thing, right? So if you're for sure gonna go, then sign up so that they can know how many people to hire, basically. Well, they're already hired. Okay. There's 2 sessions, so it's on December 17th, so the day before our final. Okay. And the first session is between 3 and 5, and the second session is between 5 and 7. And so there's going to be Math 114 review session. By SL leaders. Okay. On Monday, December 17th, and there are 2 sessions. 3 to 5 and 5 to 7. So please sign up. If you plan on attending. The room is unfortunately TBD, so I'll just I'll send an announcement when finalized. I don't have anything to do with that, but I'll just relay that information. Okay. So if you're interested at the end of class, then you can come and sign up, right? And then they'll have just a rough idea of numbers. Okay.
So we cover all the chapters?
Yeah, I think they'll probably focus on the later ones, right? Compound interest annuities. But I'm sure if you have some questions about some earlier sections, they'll probably have some material for you to review too. Yeah. So it's nice because you get to see some other practice problems other than the ones that I've given you. So, cool. All right. What are we doing? Let's just keep trucking through this TBD. Yeah. Yeah, I wish they knew before they sent it out, but I guess they want to know how many people are coming before they book a room, blah, blah, blah. So let's see here. Where were we on this dear old practice? Oh, we did the equal payments, right? So if we're looking at our list from last day, which you probably haven't, oh, not November 28th. which you have from last day, we finished up to that first compound interest, right, where we had to solve for the unknown payment. Okay. And then after this is going to be review part 2. So give you an idea of what to expect for that compound interest problem that you have to do by hand. Right? You can check your work with your calculator, that's great, but you have to show all your work by hand. Okay? And then we'll do an annuity by hand, right? What to expect for this annuity that you have to do by hand. Again, you can check your work with the calculator, but you have to show all your work by hand. And then the 3-part annuity, the 2-part annuity, and then finally mortgages we'll get through. Okay. Cool. Any questions before we get started? Nice. So final exam, review, part 2 of 2. Wah, wah. But I think I've said it before, if you're anything like me, everything just makes more sense at the very end of term once you've seen everything. You kind of got like, oh, okay, well, if I can handle all this, then I can handle it all, right? So whereas throughout the term, it's like, oh, and then there's this random thing and this random thing. So let's see here. We did that one. Just keep. Any questions before we get rolling here? Okay. So you'll have these solutions, of course, and then I've got solutions like this, but they're from last term, so but they basically follow the same structure that we've been using, right? Same idea. I got a little more thorough this term. That's why I'm, yeah. But I'll post these so that you have just the one document as well. Okay. So as far as what question is this? This is your compound interest by hand. So what is the value 1.5 years from now of the following payment stream using a 4.1% monthly compounded rate of interest, right? So we've got compound interest, of course. A payment 1 year from today of 15,000 and a payment 6 years from today of 2,000. All calculations must be done without the help of the time value money functions of your financial calculator, right? So you have to do it by hand, essentially. So, so we want to find the value at 1.5 years, right? So that's going to be a tick. But then we've also got a payment 1 year from today and 6 years from today. And because they're all referencing today, I'll put today on there as a tick as well. And so I'm going to have 4 ticks. So I'll start today. And then the first tick is at 1 year. Second tick at 1.5 years. And then the fourth tick is at 6 years. So we want to know what's the value at 1.5 years. So 1.5 years has to be our focal date then, right? There's no other option because we want to know what's the value of all these things at 1.5 years, right? So I'll just make a note here, right? This has to be our focal date. And so the payment at 1 year and the payment at 6 years have to get pulled to 1.5 years. So we've got a payment of $15,000 and then a payment of $2,000. The payment of $15,000, right? That's getting pulled forward, so it's going to be a future value. Call it future value 1. And then this 2,000 is getting pulled back, so it's going to be a present value. I'll call it 2, right? I'm just using the subscripts to denote the order of my calculations. And then finally, add those up to get the total value 1.5 years from today. So we have to have, okay, so we know our R is 0.041 and we're compounding monthly, 12 times per year. So I is R over F, 0.041 over 12. Where did I put that trusty calculator? .041 over 12. 0.0034166 repeating. I'll just make a note that I'm storing this in 1. Finally, on our arrows, right, we have to put N, the number of compoundings, right? For just these compound interest problems, right, N is the number of compoundings, whereas for the payments, right, when we have regular payments, we have an annuity, then the N is the number of payments instead. So here, N is time times the frequency. The time of this arrow is between 1 year and 1.5 years. Right? So it's really just half a year. Okay. So careful with that. 1.5 times the frequency, or sorry, 0.5 times 12. So we've got 6 compoundings in there. Here, time times the frequency between 1.5 years and 6 years is 4.5 years. So 4.5 years times 12 is 54 compoundings. So now we can get to work and calculate this future value 1. Remembering that we have just compound interest, right? So we have to stick in the compound interest formula, PV times 1 plus I to the power of N. The present value for future value 1 is 15,000 times 1 plus 0.003416 repeating to the power of 6 compoundings. So we've got recall 1 plus 1 to the power of 6 times 15,000. The future value would be $15,310.13856. If you wanted to round to 2 decimal places right away, you can. What about present value 2? We have the formula for the present value, so we don't have to derive it. Future value over 1 plus I to the power of N. The future value for present value 2 is 2,000, and we've got 54 compoundings. So we've got 2,000 over 1 plus 0.003416, repeating, to the power of 54 compounding. So 1 plus recall 1 to the power of 54. I'll do a little check-in, show my work step here. 2,000 divided by 1.2022388852. So 2,000 divided by that makes $1,663.562941. So the total value, at 1.5 years is future value 1 plus present value 2. So this is going to be 15,310 and 14 pennies plus 1,663 and 56 pennies. 15,310.14 plus 1,663.56. 16,973 and 70 pennies. Yeah. So even though you have to do it by hand, you've done way harder stuff by hand already, right? So hopefully this doesn't seem too bad. Just got to map out what you have to do. And then just do it.
So can I use the focal day as today?
You have to use 1.5 years. And the reason is because we want to know what the value, so what's the value 1.5 years from now? So the only way to find that is to use 1.5 years as the focal date. Yeah, good. Good. I'll even, there. Any other questions about that one? Pretty good. Nice. On to the next one. If you're having a peek at that list I gave you, this is going to be that annuity that you have to do by hand. Oops. Yeah. Okay, what do we have going on here? So Herbert decides to invest $1,000 at the beginning of each month to his RRSP. Okay. So now he's making regular payments of $1,000 at the beginning of each month, right? So that makes an annuity, right? When he's making these regular payments. If money earns a rate of return of 4.5% compounded annually, what amount should Herbert expect to have in his RRSP after 10 years? Do all calculations without using the time value money functions of your financial calculator. So you have to do it all by hand. Okay. So first, let's map it out, see what's going on, see what we have to find. And so first thing I'm going to do is, so he's making payments at the beginning of each month, and money is compounded annually. So just like we've been doing, I'm going to say, make little notes here. So we're at the beginning, making this an annuity due, right? So we have to use the annuity due formulas. And the payments per year is monthly, and the compoundings per year is annually, so just one. in terms of F1 and F2, right, our compound per year is just always F1. Our payments per year is always F2. These aren't the same, so we have to find I2. Let's just get it out of the way, right? So let's see here. R is 0.045, and I1, call this R1, R1 over F1, 0.045 over F1, which is just 1. So it just stays 0.045. Okay. So now we can find I2. I2 is 1 plus I1 to the power of F1 over F2 minus 1. Okay. So we've got 1 plus 0.045 to the power of 1 over 12 minus 1. 1 plus 0.045 to the power of 1 over 12 minus 1. So we have an I2 of 0.00367489. I'll store this in 1. Because regardless, we know we're going to have to calculate I2. So now let's see here. Let's make our timeline. So he's going to start today, and then what amount should Herbert expect to have in his RRSP after 10 years? Right, so he's going to make these payments for 10 years, and then we want to know how much does he have saved at 10 years, right? Making all this a future value calculation. So we want to start today, and then here we're at 10 years. I'm writing it up a little bit higher because I want to leave room for how many months that is, right? Because he's making monthly payments. So it's been a while since we did some annuities, it feels like, right? But we do our 1 month, our 2 month mark, and then just dot, 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 and then the last 2 ticks. So 10 years, of course, has 120 months. So the second to last one is at 119 months. Okay. How do we show that these payments are at the beginning of each month? We have to start with a payment today, and then the last payment is at 119 months, right? So if they're at the beginning, we shift all these payments over, right, to start today, and then they end at the second to last one. And how much is he paying? $1,000. $1,000 here, $1,000 here, $1,000 here, and $1,000 there. These are all going to make some future value due, right? Because it's an annuity due because the payments are at the beginning. And on here, on this arrow, we're just going to put N is time times the frequency of the payments, which is 10 years times 12, which is 120. It's less important for annuities just because you've got the 120 mark on your timeline already, right? To indicate how many payments you have. I like to be consistent. All right. So we just have to calculate one future value due, and that's the amount that he's going to have saved after 10 years. So we're going to figure out what that is. We already have I2. Oh, I hope I stored it. I did. Phew. Okay. So, all right, let's get to work. Future value due. Is the payment amount, and make sure you're looking at the right formula, 1 plus I to the power of n minus 1 over I times 1 plus I. Our payment amount is 1,000 times 1 plus 0.003674,809 to the power of n, which is 120, right? The number of payments, minus 1 over 0.003674,809 times 1 plus 0.003674,809. Ran out of room. Okay, start with the brackets inside the brackets and move your way out. So plus 1 to the power of 120, subtract 1 from that, divide by recall 1. I'll jot down my, if you go straight to the end, that's fine. 150.4756741 times 1.003674,809. So times that times 1,000. He's going to have 151,028.6435. He will have saved 151,028.64. So even though when I say you have to do it by hand, right, you've done way harder stuff by hand. I'm thinking about test 3, where you had that massive question that you had to do by hand, right? This one's kind of a walk in the park by comparison, right? What could change here in this question? Obviously, the frequencies can change. Maybe the payments are at the end, right? Making it just an ordinary annuity, changing the formula just slightly, right? Or what if we're paying off a loan, right? How much was this loan amount? That would make it a present value, right? I'll say this much, it's just gonna be a present value or a future value, right? So I'm not gonna make you calculate N or anything crazy like that, right? Just, it's either a present value or a present value due, or a future value or a future value due. Those are your 4 options for this, right? So pretty reasonable for having to do it by hand. Any questions about that one? Nope. Let's see here. So as far as the question that this is an annuity question, and it's going to have 3 parts. You'll see what I mean in a second here. So I kind of mentioned it last day, right? So think back to test 3, where I can't remember if it was Ernie or whatever, but someone's making payments, and then he transitioned completely right away to getting payments. Okay. Now we're inserting this little time frame where he's going to be making payments, right? Saving some amount, and then he's going to let that sit there, right? That's just normal compound interest until he can get some payments, right? Or until he retires or something like that. Okay. So let's read this one. So you've decided to invest in your RSP over the next 23 years. So you're going to be investing for 23 years. Okay. And you intend to make bi-weekly contributions over this time period, with the first one beginning today, right? So that's at the beginning of each bi-weekly period, right? If you're starting today, it's at the beginning. When you retire in 30 years, okay, so you're only making payments for 23 years, and then you're just going to let whatever you have saved sit until 30 years from now. Right? You would like to receive $1,500 month-end contributions for how long? For the next 25 years. Right, so you're making payments for 23 years, and then you let it sit there for 7 years. Right? And then you want to get payments of $1,500 for the next 25 years. Okay. So if your investments earn a rate of 8.25% compounded quarterly, so same interest rate for all of these, right? Before we had different interest rates, messing things up. Okay. Then what bi-weekly investments should you make over the next 23 years? Okay. Let's see here. So we've got 23 years, and you're going to make bi-weekly payments. And the first one beginning today, I'll just underline the beginning, right? Because it's at the beginning of each bi-weekly period. And then you're going to get, so the other payments, right? The payments that you get, you want end of the month contributions for 25 years, and interest is compounded quarterly. So it might be easiest just to jot this down as a timeline, figure out what's going on, right? And then solve for the rest. So we're gonna have something like, lots of space. We'll start today, and then the 23 years, I'll actually put it up above, right? Because I wanna know how many bi-weeklies are in 23 years. So 23 years. And then here at 30 years. And then for another 25 years, so in relation to today, right, that would be 55 years. Because in between here and here is 25 years. Okay. So mapping out these payments, we've got bi-weekly contributions. So 1 bi-weekly, 2 bi-weeklies, ... 23 years has how many bi-weeklies? 23 times 26, 598 bi-weeklies, making this 597 bi-weeklies. Hopefully you have more room than I do. Make sure I'm not forgetting anything. Good. So you're going to make a payment today. Right? So you start with some unknown payment amount and a payment today. Because if you finish, so what biweekly investments should you make over the next 23 years, right, for this to happen? We want to find that payment amount. So it's the same setup as the question we had on test 3, right, just with a little bit of a gap. So you've got a payment here, and then your last payment is at $597. And these will funnel to some future value due at 23 years. Those are going to sit there and become some present value. So we set it equal to some present value. The arrow of this is actually going to change. Okay. But I just want to show you how it would happen, you know, in our minds, but in our calculations, because we know the payment amounts for the last 25 years, we'll have to work backwards from there. Okay. So just keep in mind that arrow is going to change, but for our purposes right now. Yeah. So the present value just sits there. So the future value due becomes some present value, right? And then all we know is that it has to sit there for, or it gets to sit there for 7 years, just accumulating interest. Okay. Becoming some future value. And then what else do we know? You want to receive $1,500 month-end contribution. So you've got 1 month payment of $1,500. Two months, $1,500. And then 25 years, right, is the length of time. So 25 years has how many months? 300 months. So up to 299 months. Da, da, da. And they're at the end, so we go right till the end. So these payments, we actually can figure out what the present value of these guys are. And that's just an ordinary annuity, right? So just a plain present value, which has to be equal to this future value. Right? And here's what I said. So this arrow, right, in terms of our calculations, it's actually going to go this way. Right? And so our calculations have to go something like, so we have to start here, 1, and then this becomes this guy, and then we have to find that guy, and then we have to go make that the future value due, and then you can find the payment amounts. Okay. So we kind of snake through all of this. Okay. You don't have to. But as long as you're kind of seeing that, okay, well, if I know these payment amounts, that's where I have to start, right? And so, okay, what's the next thing I can find? I can find this present value. That's going to be the future value of just this compound interest problem. Then we can find the present value, use that as your future value due, and then you can find your payment amount. As long as you see that, you don't need those orange arrows at all. Okay. Let's jot down some information here. Right, so for this first section, these payments were at the beginning, and the payments per year were bi-weekly, so 26. And the compoundings per year for all of these is quarterly. So F1, F2. Here, this section, this is just, I'll just call it regular compound interest. With R equal to 0.0825 and F equal to quarterly. And then for this third section, right, we've got payments at the end of each month. And we've got how many payments per year? Monthly, right? 12. And compoundings per year, still 4. I would recommend that you just use your calculator for all of these, right? It's a lot of work to do it by hand. It's definitely possible, right? And you have the tools to do it. But in terms of just kind of saving you some time, I would use your calculator. And so I'm going to use the calculator. Okay. Yeah. Mm-hmm. So the first step, so first find, I'll put little subscripts on here. Present value 1, future value 2, here's the 3, here's the 4th. Making my timeline even worse or uglier. So first find present value 1. Okay. So on our calculator, we've got N, interest per year, present value, payment amount, future value, oops, skip that one. Future value, payments per year, compoundings per year, and beginning or end. That says beginning. So for N here, I'll just jot it down, right? So here we've got N equal to 300 months of payments. Okay. For this regular compound interest, N is time times the frequency. Time is 7 years times the frequency of 4. $28 compoundings, right? That's going to be kind of tricky to keep track of, right? Your calculator does it for you, but you still have to know how to find the number of compoundings. And for this, I guess, first one is 598. I didn't have enough room. Okay. So for this first one, we've got an N of 300. The interest per year for all of these is 8.25. All right, so that's not going to change for any of these. So once you have it entered, you can just leave the interest per year. And the present value is what we want to find. The payment amount that we want is $1,500. The future value of these is going to be 0. Positive payment amount, right? Because we're getting these payments. And then we've got payments per year, which is going to be 12 payments per year, and the compoundings per year is 4. And we're working at the end of each month. All right, so 300 for N, 8.25 for interest per year, 1,500 positive for the payment amount, 0 for the future value, and then the payments per year is 12, compoundings per year is 4. And just make sure you're at the end, compute the present value. So we would need a present value of negative 194.2953. Going back to our graph here, right? Present value 1 has to be the same as future value 2. Okay. So we know present value 1 is the same as future value 2. So use future value 2 is equal to 191,154.30 to find PV3. Right. So again, I'm just going to use my calculator. Remember how we use just regular compound interest on the calculator? We put a 0 payment amount, and then the payments per year and the compoundings per year just have to be the same. Right? And so we've got N interest per year, present value, payment amount, future value, payments per year, compoundings per year, and beginning or end. The number of compoundings here is 28. 7 years of quarterly compoundings. I'll just make a note here, right? Number of compoundings. The interest per year is still 8.25. The present value is what we're trying to find again. The payment, we set it equal to 0. No payments for regular compound interest problems. The future value is going to be the 191,154.3. So let's see if we make it positive or negative. So we're making payments, right? So I'm just making my way through here. So we're making payments, and then in here we get some amount, right? Some future value, that would be positive. But then we invest it again, so it's going to be negative. And then here we're kind of getting that amount, right? But then we immediately turn around and pay it. So for this section, it doesn't actually matter, right? But technically that future value is positive. And then we turned around and immediately invested it and bought this investment that pays $1,500 a month.
You said earlier, one is positive, the other one is negative.
Yeah. Yeah, so your calculator will give you an error if you don't have one of them as positive or negative, right? One has to be negative, one has to be positive. And in this case, it doesn't actually matter which one's which. Okay. So we said that, okay, well, at the end of this, we're gonna get, so I'm making a positive 154.30. And then payments per year have to be the same as the compoundings per year. The compoundings per year is 4. And so the payments must be the same. And we're at the end because there are no payments, so it doesn't really matter. 28 for N, 8.25. I don't have to, but 0 for the payments. 191. Oops. 154.30 for the future value. Payments per year is 4. Enter compoundings per year 4. Great. Compute present value. Present value. Then you get up 1,000 or 107,000. Yikes. I guess that makes sense. 927.0766. Right, so that 107,000 is going to sit there for 7 years until it grows to 191,000, because that's what we need to sustain these payments. So now we know that, looking at our graph, present value 3 is the same as the future value due 4. We know present value 3 is equal to the future value due 4, which is going to be 107,927.08. Okay. So we use this to find the payment amounts. So now you have this future value due, and you want to find the payment amount, right? And so you're going to use the appropriate future value or present value formula to find the payment amounts. And so you know the future value due, so you're going to use the future value due formula, okay, to solve for the payments. So we have to use the future value due. Oh, I guess we could just use our calculator. I like solving stuff by hand. All right. Too easy. I know you guys were hoping for this question to be harder. We weren't. Okay. So we've got 598 payments. We know the future value due. Because we're making payments, these are going to be negative, right? And then our future value would be positive. So our future value due is 107,927.08. Oops. And we're making biweekly payments per year and compounding 4 times per year. And we're at the beginning. Make sure you change that. We want to solve for the payment amount. Now I've forgotten what N was. 598. The interest per year, 8.25. The present value, he's going to start with $0. Okay. 598, 8.25, 0. Solving for the payments, 107,927.08. Not sure what that was. Future value. And then the payments per year is 26, and compoundings per year is 4. And we also have to change the beginning mode, so second and then the PMT button, and then second enter. You should have the little begin reminder up at the top. It's been a while, so figured I'd remind. And then we're going to compute the payment amount. Payment is negative $600 nope, just $61. 0.7248259. We will need to make payments of $61.07 bi-weekly for 23 years in order to get $1,500 a month 30 years from now for 25 years. Oof, that's a mouthful, right? But with your calculator, even though I tried so hard to get us to go to doing it by hand, you don't have to, right? On your calculator, it's really not that bad. I'd say this, figuring out what you have to do and how they'll relate to each other, that's the hard part, right? Once you see it, then you're like, okay, well, then I just gotta calculate that, set that equal to that, and kind of domino your way through it. Okay. Any questions about that one? Okay.
So how would you simplify it to when you said that's the one getting all those values? Just a few things simplified.
I just map out everything that I am given, right? Just kind of piece it together, and yeah, that's all you can do. Kind of map out everything that you have, and the key is to be able to set those things, like present value 1 is equal to future value 2, recognizing that those would be the same, right? And forming that link. I would argue that that's probably the hardest question on the final. But because you can use your calculator, it's not even that bad, I think. But what do I know? So if we go to our list, this would be the annuity with 2 parts, right? So that deferred annuity, which we just saw one in class, so it's nice to go through it again. So you haven't seen one on a test before, but considering we just handled the bigger one, we can handle this smaller one. So Ernie currently has $14,000 in his RRSP. He'll let it collect interest at a rate of 3% compounded monthly, and then he's going to retire when he has enough money to purchase an annuity that pays $1,500 at the beginning of each month for 20 years. So we don't know how long that's going to take, right? So this is where we have to find time. So while money earns 6% compounded weekly. One thing to note, right, is that we've got 2 different interest rates. So for one interest rate for when it's sitting there, and one interest rate for when we're making or getting payments. So we got to keep track of that. And then how long will Ernie need to wait until he can retire, right? So how long is this going to take? So first, I'll just highlight here that first it's compounding monthly, and then interest is compounded weekly. So we need to keep that, as well as the different interest amounts, right? But the payments, there's only one set of payments, and he wants to get payments at the beginning of each month for 20 years. So if we try to map this out, so today, and then at some point, so some unknown point, he retires. Party time. And then here, this length is 20 years. So we know the length of time that we need to get these payments for, right? So this is going to be the exact same idea as what we were just dealing with, right? It's just we've cut out one of the parts, okay, that last part. And so we need payments. And so he's going to retire when he can purchase an annuity that pays $1,500 at the beginning of each month. So here I'll do 1 month, 2 months, and 20 years has 240 months, making this 239, And he wants $1,500 at the beginning of each month. So we've got the first payment here. Oops, $1,500, $1,500, $1,500, $1,500. Right, no payment at the 240 mark. And so this is an annuity due, right? Because the payments are at the beginning. So we can figure out what the present value due is, either by hand or on our calculator, doesn't matter. And then we're also told that he's got this 40,000 that he's going to let sit until it becomes some future value that has to be equal to that present value due. So that 40,000 for some unknown amount of time. So n equals question mark. Here, we've got a rate of, so he'll let it collect interest at a rate of 3% compounded monthly. And here, we've got beginning of the month payments, and our payments per year is monthly. And our compoundings per year is weekly, 52. R1 is 0.06. I'm going to use my calculator, so I'll skip finding I2. Oh, what? You can do that? No. I won't take marks off if it's missing for this one. So, oh, all right, let's find I2. You got me. 0.06 over 52. .00 1153846. I2 is 1 plus I1 to the power of F1 over F2 minus 1. It's 0.0, oops, 0.0115386. And we've got 52 over 12. Can I? Minus 1. To the power of 52 over 12 minus 1. I2 is 0.00500964. Oh. And here we've got just I is R over F, 0.03 over 12. Oops. You know what? I'm going to store this in 1. Just in case. 0.0025. You know what? This one's so breezy. Let's just do it by hand. You can check your work with the calculator, and you're allowed to do it on your calculator, of course. Right? But it's nice and fun. Okay, so same idea. We've got these $1,500 payments. That's going to be worth something when he retires, right? And then, so that 40,000 has to grow to that amount, right, when he retires. And we want to know how long is it going to take for that 40,000. Yeah. No, it shouldn't. It should give you the same thing because there are no payments. So it shouldn't matter. Try it. But it shouldn't. Okay. So I'll make a note here. Can do using calculator. Doing by hand here. So first, we need to find that present value due. I haven't even numbered them because there's so few calculations. So the present value due, just going by the formula, is your payment amount times 1 minus 1 plus I to the negative n all over I times 1 plus I. We've got a payment of 1,500 times 1 minus 1 plus 0.00500964, bless you, to the negative, how many payments? 240. Right, 240 months in 20 years, 25 years, can't remember. Over 0.00500964 times 1 plus. I've had someone ask me this in the other section. Is it okay to just write recall 1? Yes. What? Fine. Recall 1. Exactly. I've made you do it the hard way this whole time. So you can have some shortcuts on the final. As long as you've told me that you've stored this in 1, then it's okay. Okay. So I'm just doing this all in 1. 1 plus recall 1 to the power of 240 negative 1 minus that guy divided by recall 1 I'll make a little pit stop, show my work here. You don't have to, you can go straight through. 139.4510556 times 1 plus, oh, you know what? 1.00500964. Times, oops. I hit a wrong button, so are you guys getting 210,000 something? Great. 210,224.4794. We need to know how long it will take, right? It will take for $40,000 to grow to $210,000. Might be a while till he retires, and 48 pennies. So now we're back into just this regular compound interest, and we even have this N formula, right? So we can just use that. So N remember is the gateway to finding time, right? We first have to find how many compoundings or how many payments, and then we can find the time that it takes, or the time that that is. So the log of the future value over the present value over the log of 1 plus I. This is the log of 210,224.48 divided by 40,000 over the log of 1 plus, I think it was 0.0025. Right, because we had to calculate that new I for this section because the interest rates were different, but also because we have compound interest. So that's important. So I'll start by simplifying the 210,000 over 40,000. 210,224.48 divided by 40,000. And then the log of that makes 1.659296458 divided by and then 1.0025, and the log of that divided by 0.0024968. Recall 1 divided by that answer. I think I loved it. Divided by 0.0025. There. Yeah, I was getting like 0.13, which was wrong. Not sure what happened. 664.5478862. We're working with N, right? We know we have to make, or we have to wait a little bit longer, right? Because we have to wait for a complete compounding. And so we would need N equal to 665 compoundings. And n is time times the frequency. We're trying to find the time that is. So 665 is the time which we're trying to find. And the frequency of these compoundings was monthly? Nice. No, it's the first one. Yeah, that's what threw me off too. Or it just threw me off, not 2. 12. I was looking at that second interest rate. So 665 divided by 12, the time it's going to take is 55.416 repeating years. So roughly, right, 55.42 years. Almost 55.5 years. But you can just leave it as decimals. Did anyone do it on their calculator? Again, the same thing. Nice. The solutions that I'll post, you'll have these ones, of course, but on here, I've just used the calculator, so got options for checking. Any questions about that one? Yeah. Yeah, so you can use your calculator to solve for n, but then once you have your n, you have to round it up and then solve for time. Cool. No more questions about that one? Yep. Sure is. But you're welcome to use your calculator. I just wanted to show you, give you some options. Here, our favorite, probably, I'm guessing, the mortgage question, which is also the last long answer question, right? So you purchase a $500,000 home in Kelowna, and you're going to make a 10% down payment and repay the remainder of the mortgage at a rate of 3.9% compounded quarterly. So calculate your end of month payment if your amortization period is 25 years. So first thing we're going to do is find the payment amount. Right? We can just go straight to using our calculator if we want to. And interest per year, present value, payment amount, future value, payments per year, compoundings per year, and beginning or end. So first, let's figure out, so 500,000 less the 10% down payment, right? So 500,000 times 0.1, I think we're all okay with it being 50,000, right? So the present value of the loan, right? You get this amount and you put it towards some house. So the present value must be 450,000. And that's just from 500,000, oops. 500,000 minus 50,000 down payment is 450,000. We have to solve for the payment amount. Once we're all done, the future value of this is 0. Right? And we're making end of the month payments. And interest is compounded quarterly. The interest per year is 3.9. And N, so for 25 years, so monthly payments for 25 years, 300. So we've got 300 for N, 3.9 for the interest per year, 450,000 present value. And payment we're solving for 0 for the future value, 12 payments per year enter, and 4 compoundings per year enter. I'm still in beginning mode. I don't know about you guys, but I'm just gonna change it. Oops. Instead, I hit compute payment. Let's see here. Second. And then compute. Compute payment. Payment is -2,347.375,904. So payment amount is 2,347.38. While we're at it, right, it doesn't ask for it. We may as well solve for I2, right? Because that's what we have to use to find our interest amounts. So we know that we've got payments per year is 12 and our compoundings per year is 4. Right. F1 and F2, these aren't the same, so we have to find I2. So R1 is 0.039. So I1 is R1 over F1. 0.039 over 4. 0.039 over 4. 0.00975. So I2 is 1 plus I1 to the power of F1 over F2 minus 1. 1 plus 0.00975 to the power of 4 over 12 minus 1. Plus 1 to the power of 4 over 12 minus 1. 0.003239494. And of course, I'm going to store this in 1. Nice. So now we're ready to fill in this table. So we want to construct an amortization table for the first and second payment. So we need our payment number 0 and then 1 and 2 and then ... The 250th and the 251st, the 250th, we need the balance at 249. Right? So we need 249, 250, and 251. And then the final 2 payments, how many payments did we say we had? 300? Nice. So then start from the bottom here. 299, and that means we need 298 as well. But we just need the balance at 298. So for the first row, we've got nothing, nothing, and then just the balance, right? The first amount owing, 450,000. You didn't. Here. Where'd it go? Right, so that's our first balance. Now we have everything that we need. We can fill in the payment amounts because we know what they are. Right, 23, 47, 38. And they're going to be the same until that last payment. Which we have to calculate. Blah, blah, blah. If you wanted to do dot, dot, dots, that's fine by me. Okay. So we've got our I2 stored in 1. Sure. So now, first thing we do is we calculate the interest on 450,000. So times recall 1. It would be 1,457. And then just going to 2 decimal places right away, right? Because we're dealing with money, we just need to go to 2 decimal places. So then we've got 2347.38. You know what? I'm going to store that because we use it a lot, right? But we want to store it with just the 0.38. Store it wherever you'd like. I'm pulling a braid and I'm storing it in 0.
You just the interest rate should be 0.
Okay.
Should be 1.
Oh, 1 or 9, huh? Oh, okay. Okay. You heard it here first, folks. 9's so far away, though. It's like a little too far. That is true. Now, I feel like a chump putting it in 0. Doesn't matter. So we've got 2347.38 minus 1457.77. So $889.61 is going towards paying off the balance. So now 450,000 minus 889.61. Now we owe 449,110.39. Can even store that if you want to. Just curious, where are you going to store it, Braden?
That I won't store. I'll use it right away.
Show off.
Just leave it on the screen.
Yeah, but what about when we subtract the principal?
Once I've got the principal, I change it to a negative and add 4.
Okay. I'll store it in 3. Doesn't matter. Times recall 1. Now I got to keep track of what I've stored where. 1454.89. Okay, here we go. Recall 0 for me. Minus 1454. Oops. Helps if I enter it correctly. 0.89. 892.49. And so now I've got recall 3 minus that previous guy, 448, 217, 90. Dot, dot, dot. We have to find the future value, right, at 249 or 249 payments. And so I'll just show my work down here. You actually don't have to show anything. All I'm looking for, right, is this table. Right? So if you don't want to show any work, that's fine, but better hope your table is all good. So we've got, so we need future value at payment number 249 and interest per year, present value, payment amount, future value, payments per year, compoundings per year, beginning or end. Shortened it. Cutting all kinds of corners. So N has to be 249. The interest per year, 3.9. The present value is the 450,000. Your payment is negative 2,347. Not sure what it's doing there. 0.38. Future value is 0. That's what I'm trying to find, sorry. Payments per year, monthly, compoundings per year, no, I can't remember. 4. $249 for Ann, 3.9. I guess you have these from before. 450,000 for the present value. 2347.38. Negative for the payment amount, and everything else is good. So I'm just going to compute your future value, and I get a future value of 110,184.0044. So in here, and it's negative, but that's just because if you decided to pay off this mortgage entirely after 249 payments, you would have to pay 110,000 whatever. And so here, don't know this, don't know this. This is 110,184. .00. Weird. Let's find the future value at 298. At payment number 298. This all stays the same except for your N. And like I said, you don't have to show your work here. I just want you to know where everything's coming from. N is 298 now. 3.9, present value is still 450,000. Payment is negative 2,347.38. 12, 4, and so I'm just going to change my N 298 and then compute the future value. Future value is negative 4,669.986,528. So on the table, don't know this, don't know this. 4,669.99. It's on sale. Oh. How about together we can just fill in the last few payments. Obviously I'll fill it in before I post the notes, right? But I think we all get the idea of the middle section. Okay. So we're gonna have 4,669.99 times I2. Now we have to pay $15.13 in interest. and recall 0 minus 15.13. I get to pay $2,332.25 towards the principal amount. So I've got $4,669.99 minus previous. So what's left owing is $2,337.74. Here's where everything kind of goes backwards, right? Because we need to have a balance of 0, but we also need to pay off the $2,337.74. So we have to pay that as our principal, but we also have to pay interest on that amount, right? And so we calculate the interest amount just like we have been doing. $757, and then your final payment is $757 plus $2337.74. Plus $2337.74. 2345.31. So that last payment's always going to be similar, but just a little bit different. So for the very last question, I ask you, what was the total amount of interest that you had to pay on this mortgage? Right, so the total paid is 299 payments of $2347.38. 299 payments of $2347.38. Plus one payment of $2345.31. So 299 times 2347.38 plus 2,345. I get 704 to 11.93. The total paid. So then the total interest paid is the total paid minus total owing. $704,211.93 minus $450,000, right? That's how much we borrowed. Oops, minus. In interest, we paid $254,211.93. Yikes. You guys getting the same thing? All right. And that's it. That's it for your final. That's pretty good, right? So I'll post the solutions to the short answers, but I think you deserve a little break. You'll be able to look them over later. All right. So I'll be around the 12th and the day of the final, the afternoon before. But if you have any questions, then just text me or email me and I'll answer. See you later. Oops.